Hello. Welcome to Editor Scripting for Noobs. I'm happy that so many noobs found their way here to learn a little bit about editor scripting. In my community, I'm a little bit of the editor scripting guy because at every event I go to, I talk about editor scripting. I like it a lot. I use it for everything. And so today this talk is a little bit about an introduction into editor scripting, but I found that editor scripting is such a broad topic that there's always a gold nugget here and there for everyone. So hopefully there's something you can find that you haven't known if you know editor scripting before. Actually, I would like to know that a little bit about you. So who here thinks he is an editor scripting master and knows everything inside out about editor scripting? One? All right. So who is using editor scripting regularly but feels like there's still more to do, more to learn about it? Great, great. Okay, so who has dabbled with it, but then left it aside? It's just too broad, too big a topic to get into. Okay, couple. And then who has never used editor scripting before? That's awesome. So we have a good mix. I hope there is something in here for everyone. There are a couple of nuggets in there that are a little bit more advanced. So hopefully some of the more advanced people can get something out of that. Otherwise, I did another talk about editor scripting at Unite 2 years ago, and that talk was called Editor Scripting from the Real World. And in that talk, I just brought my projects that I did. I've been using Unity for over 10 years now, I just brought my editor scripts and showed how I use editor scripting and what to do with that. So if you kind of want some inspiration of what you can do with editor scripting, I recommend watching that talk. It's up on YouTube on the Unity channel. And what I took away from that talk is that was because I brought my own projects, I couldn't share the code with the audience, and that's why I designed this talk from the ground up to basically create an editor that you can download later on, and then just look through the code and see what I did. I'm covering a bunch of different topics, so maybe at some point it may be a little bit too fast, but you'll be able to download the code afterwards, get the complete project, and just I tried my best to comment it, but yeah, you will just see how I was doing things. So a little bit about me. I created this editor scripting window, the talk info down here. So I'm Oliver Eberlei. My game company is called Hammer Labs. I founded that roughly 5 years ago, based in Germany, and I'm doing basically my own games. And for the last 5 years, then released three games now on Steam, and working on a game for consoles right now. So I also created a launch title for the HTC Vive. So I used a bunch of different systems already. And basically, editor scripting was the through line through all of those projects. I also have a tutorial series on YouTube called Let's Code Games. I did that last year, and then Gamescom came around and kind of lost momentum there. But I'm starting that back up again, including this talk. So starting next week, there will be videos going up a little bit more detail about what I did with this project. So if there's something in here that you missed or that went by too fast, check that out at letscodegames.com, and then you can watch that on your own time and at your own speed. Right. So editor scripting is a very, very powerful feature in Unity. Basically, you can reshape the whole editor to do exactly what you need for the project that you're working on right now. And the most obvious case for doing that is creating a level editor. So that's what I brought today. I created a small game, basically just copied the game Marble Madness. And the cool part about Marble Madness, if you don't know the game, let's just play it very quickly. You have this marble, and you roll around. Basically, just apply a torque, and then you roll around with a little bit of a delay, and you try to navigate your marble into a goal area. And that's basically the whole mechanic of the game, and everything else is a level design in that game. So it makes a perfect example project for creating your own level editor. So let's get started. I have a bunch of different areas I want to cover. And we're starting with basic gizmos. So starting at the very bottom. Gizmos are a very useful feature in Unity just to get some quick debug data into your scene. So you can draw stuff into your scene view that you won't see in the game view or in the game later. Just draw boxes around objects that you need to see quickly or stuff like that, or you can visualize different regions of your area of your game level. So let's see what basic gizmos can do for you. The most simple case is like this. So you can see here I have two game areas that are special. So I have this red area at the bottom, which is basically I called it the pit of death. So whenever the marble drops down into this area, and this is basically just a trigger, then the marble gets reset to the start of the level. And the second one is the goal area, the victory zone. When the player reaches this area, this trigger here, then we finish the level. But it's very useful in the scene view just to see where that is and visualize it a little bit. So we did that by, let's open this up and close all others. So this is the very, very simple way to draw the gizmos. Unity has a bunch of magic functions like the update function, the start function, stuff like that. Once you define it, Unity calls it whenever necessary. One of those functions is called onDrawGizmos. And that is basically a function that is only called in the editor view. So it will not be called in the game at all. So you can do a bunch of debug stuff in here, and you can be sure that it will not affect your game when you build it later on. And what I did here is, so you have this construct gizmos, and that is basically the construct you use in the function onDrawGizmos to do all of your drawing. So first of all, what I do here is I set a gizmo's color. You do that first, and then everything you draw after that will have that color. So you can see here I draw a red wire cube. And a wire cube is a cube that is just the lines. So you can see here, this is the red wire cube. And then secondly, what I draw after that is, with a little bit of an alpha of just 30%, I draw a full cube, full red cube, but with lower alpha value, so the whole region is tinted red. Simple. And then the second function is onDrawGizmos_selected, and it works exactly like onDrawGizmos, but it's only called if the game object is selected. So what I'm doing here is very simply I just draw the same thing, just in a different color. But you can see there that you can do a bunch of different things that maybe you have a very complicated debug graph that you're drawing and it takes a lot of time to render. So you can put that, for example, in onDrawGizmos_selected, so it's only being rendered when the game object is selected, so you can very selectively see that debug data. Something else that you can do with gizmos is something that I did in the camera here is you can draw simple lines, just draw lines, and there's a bunch of different stuff you can draw with gizmos. So you can draw a mesh, you can draw arrays, spheres, wire cubes, basically a bunch of stuff so you can make up your own debug visualization. And what I did here is, so the camera in the game follows the player a little bit, right? So when I fall down here, you see the camera scrolls down a little bit, just to keep the player in the center. And I did that by basically just in the camera script creating a safe frame values. So I'm saying here the top safe frame is at 70% of the screen, so roughly here, and the lower safe frame is at 30% of the screen, so roughly here. And whenever the ball moves out of those ranges, the camera follows suit. But in order to dial this in and make this exactly where you want it to be, it would be nice to have to visualize those regions. So that's what I did here. I did onDrawGizmos. I draw the safe frame gizmos, and basically I use the viewport coordinates. If you don't know what that is, it's basically the coordinates of the screen from 0 to 1. So the x-axis on the very left side is 0, on the very right side is 1, and the same with the y-axis. And if you go beyond that, it grows bigger or smaller than 0. So it's very useful if you want to work in camera space, in screen space. And so I draw those gizmos, but the problem is if I draw them in the scene view here, you can see, you can kind of see the safe frame here, but it's not very useful. You really want to see what the camera is seeing. And then this is something that I embarrassingly learned very, very late into my career, is there's this gizmo button in the game view, and you can select that, and then all the gizmos are being drawn in the game view as well. Of course, only in the editor, but it's very useful to see while you're playing the game, maybe to see your debug data as the main camera sees this. And as you can see here, I can see the safe frame perfectly. If I adjust the same frame here, I can make this a little bit higher, or maybe make this adjust a little earlier. And so once the ball moves past the safe frame there, the camera adjusts. So that's a very good way to dial in your systems very visually. Right, those are basic gizmos. Something I'm sure you've heard of is custom inspectors. And let's go back to the first one. You can see here the game camera has some public values, the safe frame, the speed, how fast it moves, and the distance. I actually have no idea what the distance speed modifier does, but anyway, the camera has some public values. And it's fine if you have like 3 or 4 values, maybe a couple more, it's all right to work with. But once you get like a data set that has a bunch of values in there, it gets cluttered very fast, and you kind of want to have an option to structure them a little bit. So that's what I did in the second scene here. I have the main camera, and now it looks like this. You can still see the speed and the distance speed modifier up here. Then there's a little bit of a break. So just a separator. Then you have grouped together the maximum height and maximum and minimum height of the camera. And then I have the safe frame down here, and I have actually range values. So it can only go from 0 to 1. So your game designer cannot put in data that you're not expecting in there. So it's always good to have some checks of your values and stuff like that. And what I also did here is I added a preview slider. So I'm saying here this, the maximum height, this is a new feature in this scene, is the camera should not go everywhere, but I want to define a maximum position for the camera, which is maximum and minimum height. And then I have a slider to debug this, so I can see what is the range in this level, what the camera is seeing. So I can see if basically if there are any rendering issues, or I can see if there are objects past this area that I want the player to see and stuff like that. So that is pretty useful to visualize. And this is all done with a custom inspector here. So let's see how that works. There are 2 different methods actually in use here. So let me go into the game camera first. And Unity provides you with a couple attributes that you can put on your variables, so some of the basic formatting is done without you having to create an extra editor script for it. So like this, the space here, it's just the space attribute, 10 pixels, and this is the space right here. Second one is header, so you can write stuff in your inspector, and there's no extra work required. Just put in this attribute, like square brackets, header, type in what the header should be, and then the safe frame here, that is the header that we are drawing. The next 2 ones have the range attribute attached to them, so that is attached to a float value, and then basically once you attach this range attribute, you get the slider, and in the range attribute you can define minimum and maximum ranges, so the slider knows what the outer bounds are basically. So that is very useful if you have a bunch of public variables and you just want to structure them a little bit. But what we also have is this camera height down here, and this has a little bit more function. It changes the scene, and it actually updates. So once 21 in here, it actually updates the camera height. So the maximum value is suddenly 21. That's not something you cannot do in the range attribute because those values have to be constant. So you have to do a little bit of coding yourself. Once you get into that, so more advanced editor scripts where you have to code yourself a little bit, you create what is called a custom inspector. Let me close a bunch of stuff up here. So, and a custom inspector is a specific class that that is, first of all, very importantly, it is placed in the project in a folder called editor. And it just has to be beneath a folder called editor. You can have a bunch of more folders beneath that, but one of the folders in that chain has to be called editor. And once you do that, and you can have multiple editor folders as well all over the place. But everything that is inside of an editor folder is being put into a different assembly by Unity. So you can see here in my solution file, I have the assembly, the C# assembly. This is all my game code. And then I have the assembly C# editor. And that is all my editor code. And the good part about that is that everything that's in the editor code will not be included in your game. So you know everything you do here is simply for basically your own purposes, and they will not affect the game once you build the game. And what you can do, you can actually you have some more functionality in this editor assembly as well. So notice up here, next to using Unity engines, what we all know is using Unity editor, and that is something that you can only access in scripts that are placed in an editor folder. And now you have a bunch of more functionality that you can do. And one of them is, first of all, because we are creating an editor, the class does not derive from mono behavior now, it derives from editor. And then at the top here, we put an attribute called custom inspector, telling Unity that this inspector that we're coding right now is associated with the game camera script. So whenever we click on an object that has the game camera attached, which is the main camera here, don't do what you are usually doing and draw all the public variables, but use my script instead. So this is done by just declaring a custom editor and telling Unity which type this editor belongs to. And I always basically name the editor the same name as the class variable and just put editor at the back there. Now you can override this method here, the onInspector GUI. And I mean, I'm sure you know the onGUI functionality of Unity and all the GUI buttons and stuff like that you have. And this is exactly the same thing here. You have all the GUI functionality that you're used to, but it's basically onInspector GUI. So this is called every time the inspector GUI is being redrawn, and then you can draw your own custom inspector. The first thing that I do here is call a method called drawDefaultInspector. So I do want Unity to draw what they're drawing all the time. So this is basically everything here is the default inspector. So I'm telling Unity, still do what you usually do, but I do want to do some additional stuff as well. So, but you don't have to do that. You can just create a completely custom inspector, and then Unity will not draw all the public variables, and you can design completely how this inspector should look. The second thing that I do is draw camera height preview slider. And that is basically this slider down here, and it has some logic to it. Simply, you can use GUI layout as well, GUI and GUI layout. You can also use something called editor GUI and editor GUI layout, and there are a bunch of more GUI elements that you won't have in the game. So you have, for example, color fields here, so you have the color picker and stuff like that. So a bunch of fields that you won't have in the regular GUI, you have in the editor GUI as well. So very useful stuff in there. And then basically what I do is I create a slider object in editor GUI layout, and I use the minimum height and the maximum height as the range for this slider. And this allows me to have the slider always be clamped to the values that I put in before. And then afterwards, I simply, if the position has changed to the previous position, then I want to apply that change. And you could simply, well, in this case not because this position, but you could simply apply the value directly, but I usually save the value in a different variable, so I'm able to see if I have changed that, to be able to react to changes more specifically. In this case, very simply, before I change the object, I want to register an undo step with Unity, telling Unity, hey, I'm doing something now. Register in your undo database or whatever that I did something and what I did, so the undo functionality works. So I can press Command Z and Command Y and stuff like that. So that's very useful. And we'll do more of the undo functionality later on. There's a bunch more stuff that you can do with that. And then I simply apply the value, and that's that. So basically, when I change the value here and I press Control Z, you can see it has. Wait a second. Interesting. Well, moving on. Later on, some undo functionality will be there. It's roughly the way you have to do this. I think I forgot to mark the object that it has changed as well. But later on, I have some functionality that actually that I've actually tested and it works. All right, so this is a custom editor, very basic custom editor that you can do, yeah, you can do really crazy stuff with that. All right, let's move on to the next thing. So in this scene, I introduced a new level design object called a piston. And the piston is a very simple object. When I move close, it basically changes the height. So there's a trigger around that object, and when I enter that trigger, the state changes. And then there's this stick over here that just moves me off if I want to go to the zone there. Okay, let's look at the custom inspector that I created for this. So this is a little bit more advanced stuff. As you can see here in the, I've selected that object. It has a very simple sphere collider that is defined as a trigger, and that's basically the range that reacts to the player. And then I created a script basically that reacts to the trigger. Let's look at the functionality first. Very simply, on trigger enter, so when the player enters my trigger zone, then I want to set a state, and I'll show you in a second what that means. That's a custom function of mine. And if the player exits the trigger, then I also want to set a state. And those are simply strings. So for this here, when the player enters, the up state should be set, and when the player exits, the default state should be set. All right, so what are the states? Let's move over to the piston object itself. Here you can see I have a list of piston states. And that is just a very regular generic list. Usually Unity would show us this in an array, so you can open that with your little arrow thing, and then you can see all the elements. But I added this attribute here called hide in inspector. And that is because I want to draw this list by myself. I want to have a custom script for this. But I still want to use the draw default inspector method to draw these two. So that's why I changed the default inspector. I said, okay, in the default inspector, just don't show this. If you don't write any custom scripts, you can still use this attribute if you want to hide some public properties from your level designer if they're not supposed to be changed. But if you do that, I think you kind of have other problems, like structurally, but that's fine. So let's see what the piston state is. The piston state is a very simple class that simply has a string and a vector3 position in there. One notable thing about this class, I put this attribute here, the system serializable. And that tells Unity that this is a class that I want to be able to serialize. So I want to be able to use this in an array, for example, or in a generic list. And Unity will use their own serialization methods to store the data in there. And basically, if you have like complex data types that you define yourself, you have to tell Unity this is something you can serialize. And Unity serializes everything in there that it normally can serialize. So all the default data types, vectors, quaternions, lists, whatever. So everything that Unity can serialize in a regular script, they can serialize. But since this is a complex class, basically, we have to tell Unity this is fine to serialize everything in there you're able to do. Okay, so this is basically a list of objects that have a name and a position attached to it. And basically, in the SetState method that we have in this trigger, so I basically call SetState and then call a string, and then pass on a string which state should be set. A simple thing what I do here, I just go through the list of states that we have. If I find the state with the name that I passed here, then I'm using the position that belongs to that state and tell the piston, this is your target position, move towards that position. Now, so very, very simple, but as I said before, I want to have a custom inspector because, as you can see here, I have a bunch of custom stuff in here. So I have two states predefined. The default state, which is the cube object here, is at 0, 0, 0. So it's always local to my object. So the default state is the cube is at 0, 0, 0. And then I have an up state, and basically the cube just moves 1 unit up. And I can add new states, basically just move to the left, and have it move 3 units to the left. And if I change the on enter to left now, we can press play. You can see here it moves while the camera is tilted, so left has a new meaning here in this. But you can see it now moves to the side. So I created this new state. Yeah, so and I can add a bunch of new states here. I can remove them again. I get asked if I really want to remove them. If I do, and now here you can see I'm now pressing Control Z, so the undo functionality works here, and you can see undo add new state. This is something you can do. So this is the custom inspector for the Piston script. Let's look at how this works. So the Piston editor. Again, I started with draw default inspector to draw the first two values there, and then I draw my states inspector. The states inspector starts out with just a label called states, and you have some editor styles that you can access here. For example, what I use here, the bold label style. So this label is printed in bold. And there is a bunch more, so you can design your editor a little better. And then I go through all the states that I have in my object, and I want to draw the state, call this the state function with the index, and at the very bottom, I want to draw an add state button as well. So I have all the states, and then at the bottom, I have a draw this button to add new states. Right. So this draw state now gets a little bit more complex. So let's just let this sink in a little bit, and then let's talk about that. First of all, what I do is I find the property states in this serialized object. And a serialized object is a special object that Unity gives to you. When you open a game object with a custom inspector to it, you have different ways to access the data of that component. The first is to just do target, and then this is basically a reference to your component. So you can target is not typed yet. So what I usually do in the beginning, I cast this to my actual type, so that I have the states, for example, here and stuff like that. So through the target variable, you can access, you get a reference to the component that you're modifying. And you can modify the stuff directly. You can also get access to the data of your component through the serialized object. Just like target, this is defined by the editor class. And the added benefit of modifying the data through the serialized object instead of directly in the target is that Unity does all of the undo redo stuff and has a bunch of functionality just applied for you or immediately, so you don't have to worry about putting in all that boiler work of undo redo and a bunch more. So that's useful. It's a little bit more convoluted. So you have to find the property, and then and then you get a serialized property, and you can modify the values there. But once you get the hang of serialized objects, it's actually very useful to very quickly simulate the functionality of what Unity usually does in the inspector. Then I just do some layouting stuff. So begin horizontal means all the elements that I'm drawing next should be in a horizontal line. So all of this is draw horizontal here. And here's just some fancy thing that I do. Basically, you can look this up if you get the source code and see what I do there, because this set bold default font, basically what this does is the usual functionality that Unity has when you change a value of a prefab is it renders it all in bold, so you know this is a changed value through to the actual prefab value. This is a functionality that you usually are not able to do through editor scripting, and I used a bit of reflection magic here to access that, but you can figure that out if you get the source code. But the interesting part is, so I have the label of the state, and then I use the editor GUI begin change check. And this begin change check goes together with editor GUI and change check. Basically what this does is you encapsulate an area and with editor values, and if any of those values are changed, then this end change check returns true. So you know that between the begin and end, some value has changed, which is useful. So you don't have to, if you have maybe like 5 or 6 values, you don't have to store them in, I mean, I do store them in different values, but I don't have to make the check myself. Is it the same as the old value? Then apply the changes, stuff like that. So this is a very useful function to do that. Again, I record the undo step, and then I just set the values. And this is, I think, what I forgot in the earlier undo one. I have to mark the object as dirty. And once an object is marked as dirty, you can mark a scene as dirty, or you mark an object as dirty. Unity knows that when you press Control-S, or when you save the scene or whatever, this is a dirty object, I have to save this. If you don't do this, Unity will not save your changes. So if you change values through your editor, and you don't mark the object as dirty, Unity doesn't know that your object has changed. Even though the values, you can see the values have changed, but Unity doesn't know it. So Unity only stores or saves data that are in dirty objects, basically. So remember that, and this is only if you, like I do here, if you change the values directly through the target. If you use serialized properties and change values through that, Unity does that for you. So that's also a difference between target and serialized object. And then I have a remove button here. Some cool stuff is just editor application beep. So it just plays a small, quick sound that something is happening, and then I display a dialog here. And this is a very quick way to create an inline dialog. They can be complex, so you can have like 3 buttons, or I have 2 buttons, I think, right now, which is a yes and no button. So I write really is the headline. Do you really want to remove the state? And then I have yes and no, the names of the buttons. So basically, when I press remove, this is this pop-up here. And it's a very simple thing to do this inline in your code. So you can do this very fast and don't have to create a separate window to open that and stuff like that. And if the user presses yes, this method returns true. If the user presses no, it returns false. So you can basically just place this in an if condition, and then this happens when the user pressed yes. So I delete the state, I remove the state, and then I tell Unity the object is dirty again. And then down here, add state is basically the same thing. Just a button, record the undo step, add the new state, and then set the object dirty. So this is a custom inspector that is a little bit more complex, and you can do you can do basically whatever you want with all the data types and editors that you have. I created complete item databases with that, very complex, that have very complex relations and stuff like that. So very, very useful for that. All right, let's move on. So this is something that I just hint at, and then for those who are interested, they can look at the code themselves, because this is a little bit cheeky, but still very, very useful. So what I'm using here is, this is I call this advanced custom inspector for the Piston. And this is a pattern that I can define. You can see here, this is a list. And basically the pattern object basically just defines a list of states that the object should go to. And then just with the delay mentioned here, it just applies those time-based. So let's just press play for a second, and you can see in the bottom there, the red objects, the up and down state is basically applied based on the time. But what's much more interesting is this list here, because let's add new state here. Let's add a left state as well, and the left state is up and here. And then so this list here, I can press plus, and then add a new state, and those are the states that I have defined here. So I can add the left state, and then immediately a left state is applied. I can apply the delay here. I can move them about. So basically, I can very simply, in the inspector, change the order of this stuff. So that is a very, very useful tool. Let's see what kind of pattern I created now. And there you go. So this is the pattern that I created now for this, because I added the left state in there. But yeah, so this list is very useful for all sorts of arrays, because you can customize everything about this list. You can customize the header. You can customize what is rendered for each entry in that list. So the up and the delay here, and how these buttons work and stuff like that. So let's quickly look into that, so you know what you can look out for. This is in here. And this is called the reorderable list. And the reorderable list is actually something that Unity does not want you to use yet. So it's not positioned in the Unity editor assembly, but it's positioned in Unity editor internal. And Unity editor internal is actually something, whenever a new version of Unity comes out, it's actually something I look at and see what cool new stuff is in there. Because usually Unity puts stuff in there that is not quite production ready or public ready for the public yet, but what they use internally for their own inspectors, stuff like that. So the added, what you have to keep in mind when you use stuff like what's in there is that it can change with each version. So the API is not fixed and stuff like that. But usually there's some very cool toys in there. And the reorderable list is one of them. So the reorderable list, you can define that you create a new list for that, pass on a bunch of values. Actually, in the comments here, I put in a link to a blog post that taught me how to use the reorderable list. So you can check that out. It explains very well how this list works, and a bunch of more functionality as well that I'm not using in here. But then you basically you tell the list how the header is being drawn. In my case, I simply draw state and delay at specific x coordinates. I tell how each element should be drawn. In my case, again, very simple, just two property fields for the name and the delay. So that is these two here, name and delay. And in the end here, I define how the add drop-down callback, what should happen when you press on that plus button down here, and I defined that the drop-down list should be here. Yeah, so basically into a generic menu, I add all the states that I have, and then show it as a context menu. And the last thing that I do here is basically just the callback that's being called when I click on any of the items in the context menu. So this is a very complex object, and I highly recommend to just play around with it. I always have to go to that blog post as well when I use that element, because it's very complex. So I always have to remind myself how I actually use that object. but it's very, very powerful, especially if you want to have just a reorderable list, basically, with all types of complex data in there. So, okay, so that was a quick primer to the reorderable list. So let's move on to editor windows. And in this scene, I did something that I use all the time. So when you have a game like this, for example, where you define a pattern of some sort in your level, be it how enemies move about, how they walk through paths and stuff like that. If you just want to define a pattern that the user has to deal with, it's usually very painful to define the pattern, then press play, see how the pattern plays out, make changes if you don't quite like it, stuff like that. And in my case here, I have this complex pattern here. You can see, basically, I just want to have the pistons, a piston pattern. So I can either use them as a bridge, or not, or I just have to find my way with the pattern, stuff like that. But to define a pattern like this is very complex, because each object has to be timed exactly so that it creates this kind of beautiful pattern to look at. So what I did is I created an editor script so I don't have to press play to design that pattern. First of all, what I did is, let's start differently. So I created an editor window. It's up here in the window pattern, and it's called the preview playback window. And what this gives me is basically just a couple of buttons, and I can press play. And as you notice, I'm not in the play mode right now. I'm in the editor mode. And if I press play here, I can see a preview of my pattern of the object. And I've used this for enemy patterns, if they walk along paths, to see how they move in the editor and stuff like that. So I can design in the editor and see my changes immediately, and I don't have to press play and just wait for the right time and stuff like that. And I can scrub through. So in this time I can forward and reverse. I can fast forward. Usually I always have a scrubbing slider in there as well, to very quickly navigate through the time of my pattern, to see how this works. Okay, let's see how this is created. And first the editor window. Editor window is another type that you can only access in the Unity editor namespace. And this is also a class that has to be placed inside an editor folder so you can use it. And first of all, what you need to do is, basically the window is like every other window, like the hierarchy of project and stuff like that. This is how Unity does their own windows as well. So it has all the functionality of the window. You can drag it around. You can basically you can dock it to the window, stuff like that, just like you would expect from any other Unity window as well. So that is very useful. The first step that you have to do when creating an editor window is, it inherits from the class editor window, and then you have to create a way to open it. So either you have a custom inspector somewhere where you can press a button and open the window, that's fine. What you usually do is you create a menu item that is placed, and you write the path up here. So a menu item is placed in window, preview playback window. So that is up here in window, preview playback window, and then create a static function that basically is being called when you click on that menu item. And in my case, I simply get a pointer to a window of type preview playback window, which is my type here. And what this means is I either get a window that already exists, or if it doesn't exist, Unity opens one up for you. And then you can just name it and do different stuff in here as well. What you can also do with this, which is sometimes cool or helpful, you can, in the window, you can, for example, define the minimum size. This is not useful for this window, but you can basically define how big the window can be and stuff like that, and how big it should be in the very beginning. So you can see here, I have a minimum size now. I cannot make it smaller like this. And you can see, and you know this from the project view, for example. It has the same thing, the same functionality in there as well. So you can do a bunch of different stuff with your window there. And the second thing that I did here in this window, once this window opens on enable, I attach a callback, my onUpdate callback, which is simply just a method that I define, a void method with no parameters, and I attach this to the editor application update. And editor application update is basically an update function in the editor. This gets called 30 times a second, no matter what happens in the editor. 30 times a second, all the delegates that are attached to the all the methods that are attached to the update delegate here are being called 30 times a second. So it's basically an update method inside the editor, which is very, very useful. And then I just do some very, very simple stuff. I created a class called preview time. And this basically just keeps my time. This is my editor time class, basically. So this is you can see here, the preview time is at 30 seconds now, stuff like that. And the way that I did this, first of all, is go to declaration here. I use something called the editor prefs. And I'm sure you're aware of the player prefs. It's just a construct by Unity where you can store different data. And editor prefs is the same thing as player prefs, just it can only be accessed from your project inside the editor. So if you have a bunch of debug data that you need to store, I often have data in there that is config data for my game. So config data that when I press play, this config is used, so the game state is restored to wherever I need it to be. And because it's an editor prefs, it's not in any file. It's not stored in any files. So it will not be in version control. So you will have your own config, and it will not be shared with other ones. So very useful to create basically an editor or a config for each specific user. And yeah, you have set and get float in here, and I basically just set a value or retrieve the value that has been stored previously. And so this is what I'm doing here. I get that time, and I just, in my update method, I increment that, and by the playback modifier, you don't have a delta time in this, so you kind of have to do your own delta time, which is very simple. This is something that I do here. So time real time since startup, and then I store that value in the last time down here. So the difference between the two is basically the delta time between the frame to the next. So this is why you can have a very simple delta time in here as well. And basically, every time this is called, I want to increment the preview time, I want to repaint this window, and I want to repaint the scene view. So because Unity does not do that automatically, it has some specific times when it repaints the stuff. But you can tell it to repaint the scene view as well. And yeah, and the window itself, then in onGUI, you can put all what you want to draw in the window, and this one is very simple. I just display the preview time that I have in seconds and minutes, what the current playback speed is, and then a bunch of buttons to play and stop and stuff like that. But now that I have this preview time object that is being updated 30 times a second, so I have a pretty smooth time, editor time basically, I can use this in my scripts as well. So I have I created a gizmo for this piston, the yellow box that we saw before. Again, using onDraw gizmos. And basically what I'm doing here is I calculate which state I'm in based on, let me see what it is. So based on the preview time, so my own editor time that I created, I calculate in which state the object would be in at that moment. Basically, I just go through all the states and find out which state I'm in right now. And then once I found that state, I go, once I found that state in this method here, I go to the draw gizmo state, and using the state and the last state, I can then determine which position the object would be in and just draw the gizmo at that position. So that's a very useful thing to do as well. Cool. moving on to handles. So now we get into custom level editor design. Handles are basically what you're working with when you work with the editor. So the move tool is a handle, the rotate tool is a handle that Unity provides, but you can draw your own handles as well. So that's what I'm doing here. So in this scene, I'm only drawing the handle, so the functionality is still the same. But basically what I do is I cast array, and at that position that I hit, I draw a small cube preview here. So let's just quickly go into that, because the more interesting stuff is happening in the next scene. Go to handles, editor, cube handle. So basically, two interesting things here is first the attribute initializeUnload. So you can see this is an editor again, but initializeUnload means whenever Unity loads the assembly, so on recompile or when you open the editor, whenever, this class gets created. So the constructor of this class, the static constructor, is being called. So whenever you open up, this constructor is being called. So immediately, I just attach myself to the onSceneGUI delegate. OnSceneGUI delegate is basically just whenever the scene view is re-rendered, this is being called, so I can do some drawing. And what I do here is basically just I update the handle position, which is the ray casting I was talking about. Simple stuff like you would do in the game as well. No difference here. Then I check if the mouse position is in a valid area. The cool part about this is I get a reference to the scene view, and it gives you the size and the position, stuff like that, so you can make checks against that. And then basically, if the position has changed, I will not go into this. You can, as I said before, you can get the code yourself, but I have to hurry up a little bit. And then update repaint basically it checks if the cube position has changed, and if yes, then I want to repaint the whole scene view. And basically, and here I draw the handles. So you can see here, handles works similarly to Gizmos. You set the color, and what I do here to draw the cube is basically I just draw a bunch of lines that are set up here. So I draw the cube there. But handles have one thing. I mean, similar to Gizmos, you can draw stuff, but something they can do as well is, I mean, as you know from the move tool, you can interact with them. So that's an interesting part. So let's move on to the next scene here and see what we can do with our own handle here. First of all, what I did. What you can do in handles and in the onSceneGUI delegate that I showed you before is you can draw into the scene view. So what I did here very simply is I created just a toolbar down here, so I can select my tools, similar to the Unity tools. If no tools is selected, then I use the regular Unity tools, but I can have an erase and a paint tool. So let's check out the paint tool. And as you saw here, if I go to none, I can see the handle here. Once I select the paint tool, I hide the regular Unity tools and then just draw my own again. And in this paint thing, I can now, well, 1 second. Oh, that's in the next scene, right. I'm jumping the gun a little bit. So basically, what I want to show in this scene is just you can draw your own GUI into the scene view here. So let's check that out a little bit. So the handles GUI here is the same thing. I hook into the SceneGUI delegate. There's another callback that is interesting to know about. Is basically just hierarchy window change. Basically means when the user has selected a new scene, so the hierarchy changes. So I use that when I move out of the scene. But very simply, in the onSceneGUI here, I draw the tools menu, and the tools menu is just a selection grid, and I define the none, erase, and paint. And the selection grid basically gives you a list of all the buttons that you have defined, and if you click on one of them, it returns the index of the button that you've created. So none is the index 0, erase is index 1, paint is index 2, and that's what I'm doing here. And I store that in the selected tool variable, so it's just simply an integer value up here. And again, I'm using the editor prefs to store that, so it's persistent. And I also do so when I set the value, I do some stuff depending on which tool is selected. So for example, 0 is the no tool for myself, so I don't want to hide the Unity tools if I have none selected. If I have paint or erase selected, I want to hide the regular Unity tools. And I also want to set some values so I can change the color of the cube and stuff like that. All right. So that is basically this is, and one important thing to note is basically you have to call handles begin GUI to be and then end GUI again to be able to draw GUI stuff into the scene view. Yeah, simple enough. All right, so let's go to the next scene where we can add and remove objects now. So now we get into level editor territory. I have the paint button, and when I click, I eat the click event. So I tell Unity, do not use the click event yourself. I'm using the click event, so I can change the scene, and I'm not selecting the stuff anymore. If I go to none, I'm not eating the element, the click event, so usually the Unity's default behavior applies. And then I can just paint a bunch of stuff in here. So this way I can very rapidly design my own level and yeah, create my own custom editor for that. So let's see how this is done. Add and remove objects, the editor. And again, initializeUnload, just like before. Hook into the onScene GUI here. And then onScene GUI, hooking up the mouse event is a little bit complicated, convoluted, but that's just how it is. Basically, what you do is you create a control ID. That is the construct that Unity uses to handle events in the editor. In this case, we create a passive control, which means it cannot get any keyboard input. We're only interested in mouse input. And then after we do all the stuff that we want to do, we tell Unity, this is the default control. If no other control is being used actively, so if no text error is being used or like any other button, then use this control as our default control. So do not use your own default methods, but use ours. That's just the way how Unity does it. And basically what I do here, I look for the events that we have. In the current event, if the current event is of type mouse down, if the button is 0, so if it's a left mouse button, then I do my own stuff. So if selected tool is 1, remove the block at the current handle position. If selected tool is 2, add the block, stuff like that. Down here, I just created a shortcut to go to the none tool. So basically, if the key is down and the key code is escape, I want to select the tool 0. So I can very quickly just press escape, and then I have the none tool selected again, and I can use Unity's functionality. So the last scene that I want to show, and that works pretty well with the timing, is I want to talk about scriptable objects for a second. In this scene, as you can see here, I created, I have some preview stuff here. And when I paint objects, I can select this object and then paint this now, or I can paint the green objects. So I can select different types of objects. And you can see, I can see a small preview here as well. So let's see how we did that. To be able to define what type of objects should be on the side here, I created a so-called scriptable object. And a scriptable object is just an object it's just a data object that lives in your project. So inside this here, I have this object called level blocks. And this is similar to a mono behavior, but it's not attached to a game object, it lives in your project. So if I select this, I have the same inspector just like I would have in a mono behavior. And in this type, I have blocks. I can assign them names, and I can assign them a prefab. And basically, oh yeah, you can't see it here. I designed this with the Pro skin, and then it looks like in the non-Pro skin, in the free skin, the font is not very well designed because it's almost the same color as the background. But anyway, the name that I put in here, the green-blue block, is basically displayed on the top here, and then the buttons below that. So basically just the name and the prefab, and that is the name that I want to display, and then the prefab that I want to create when this is selected. And then from that I create this window here. But the cool part about the scriptable object is that it's just a data class sitting in your project. You cannot instantiate that on accident. It's kind of like I often use it as a database, yeah, it's very useful to have shared data between scenes and stuff like that. So I highly recommend looking into scriptable objects. Yeah, and then just to show you quickly what I did here to draw this is the scriptable object editor. Again, hooking into the on-scene GUI, initializeunload, stuff we already saw before. Same thing here, stuff that we already saw before, just hooking into the mouse event. This only thing that changed here is the addBlock method just now instantiates the prefab and not just a random block anymore. And the draw custom block buttons, again, starting with handles begin GUI. I draw the background box here, and then I go through all the blocks that I've defined in my scriptable objects, and I draw that. And you can see here, one interesting thing is this line, is the get asset preview. You can simply just pass an object into that get asset preview, and it renders it for you and gives you back a texture. So this is the simple way how I created those preview stuff here. So that's all Unity doing the hard work for us. So I have this preview image, I create GUI content for that, and then I just have here a list of buttons. I use a toggle here, so again, in this skin, you can't see it very good, but a little bit. You can see it's highlighted a little bit. So I'm not using a button, I'm using a toggle with a button skin attached to it. And then if the toggle is active, then it's highlighted a little bit, so that's very useful as well. Yeah, and that's basically it. So when the button is pressed, then I select this block, and then I can use this selected block method to see which prefab I want to instantiate once I click. And that's all the time that I have. So I hope there's something useful for you here. If you want to look into this project, you can just go to letscodegames.com. I've put a download link there for the complete project. The download link will be up there for a couple of days, but later on, when I start the YouTube series about this, I move this somewhere else. So for the Unite people here, just go to that link, you can download it, and for those who look on YouTube, you can go there as well and find the links where the project is now and how you can find the tutorial about this. So thanks for listening.